Yesterday we did. Can you hear me? Yeah, I think it's muted. Welcome to today's stream. So yesterday we did the board classification types. Yesterday we did. Can you hear me? So if we go and see here in the custom mission.ai today's stream. So yesterday we did the board classification types. Yesterday we did. So this is our project we have done. Okay, I got alert here. Custom mission service is retiring limited trial projects from March 19. To ensure continued support after this date, you will have to move your projects to an Azure resource within 26 days. Okay, anyhow, we're still running on limited trial. We might be changing that soon into our Azure portal. Okay, so I will ignore this one second. So I will ignore this alert, but later we will be moving into the Azure portal. Right now it's running in the limited trial. Okay, the music is pretty loud. 1 second, I will just reduce the volume. Thanks JS to string. Is it good now? Okay, I think it should be good now. Can you hear me? Yeah, okay, good. So yesterday's stream, what we have done is we did a custom mission on this board classification type. So we find the data sets from the Kaggle. So if you go to that Kaggle image data set, so they are maintaining a lot of open image data sets. Since we are not owning this data, I think it's better to go for these public open image data sets, so that we can use this image for machine learning model and everything. So we have find that the boat image dataset, but you can go and find the other image datasets as well. For example, here a flowers recognition or fruits 360 dataset, or even a chest X-ray images to detect whether that lungs has pneumonia or not. So those kind of different open datasets that is available in the machine learning thing. So you can go to kaggle.com and download the dataset. Yesterday we have downloaded this board classification thing. So I think we have tagged a different board classification types cruise, ferry, gondola, kayak or sail, and also we have uploaded the image which is not boat, and we have uploaded that, and we tagged as a negative tag, so that even if you are uploading a image which is not board, then it would be easily identify the negative type or the out of edge scenarios, right? So those things we have done yesterday, and we did training, and that training created iterations here. So that includes one second. So that includes the iteration 1, and we have added more images and created the iteration 2. So in the iteration 2 we can see how it's going to perform, and what is the precision rate and what is the recall rate here. So those things we have seen yesterday. So today what we are going to do is we are going to export this iteration pre-trained model and try to run in the Docker container. Yesterday we tried to run, but we got some issues. So today we are going to resolve that issue and going to debug that the Docker script, why it's not running when we have run the local. So what I have done yesterday is like trying to export this citation. So you can see like you can choose your platform, including like a core ML, TensorFlow, ONNX, and the Docker file. So we are going to export this Docker file only because we are going to run this pre-trained machine learning model to do the image classification on the IoT device on the Raspberry Pi. So we are going to do that in the Azure IoT Edge. So I'm going to click this Docker file and going to download the Linux version since I'm in the Mac. Clicking download. That's downloaded this zip file. And this is the Docker file we did. I will move that into my personal folder and change that to boot classification. Okay, just to string this would be recorded, and if you want like anything, then probably I can send it to you. These videos will be shared in my Twitter, then you can come and later watch. Thanks for stopping by, and I really appreciate that. And please come by for like the future streams. My schedule is Monday, Wednesday, Thursday 8 p.m. and Saturday on 9 a.m. EST. Thanks, Jace to stream. So the board classification Docker file. So this one we are going to run. Going back to this my personal directory, board classification. Okay, so let me open that in the Visual Studio Code. So you can see here like there is a Docker file, and in this Docker file this is generating the Python 3.5 based image, and it's adding the application folder here, and it's installing that the Python requirement libraries. So the requirements.txt file contain all the Python dependencies, including TensorFlow. Basically this one is to like detect that the pre-trained model that is exported in this model.pb. So basically like the TensorFlow is going to run on this model.pb exported file, and it's going to detect like what label it is. So we have both model.pb and the labels.txt. Then Flask is for like a REST API. So basically this app.py, it's starting the a REST based server, and you can just like post your image to this route /image. Then it would be doing that predict image, and to give it would be giving that result back to you, right? So this was like yesterday we started looking into that. Then what happened is yesterday is we tried to build the image. So let's build a image like docker build -t board classification latest tag. Okay, I forgot the current directory, board classification latest. Oh, still not. Okay, I misplaced the dot. I misplaced the arguments. I think now it's right. Okay, so it's built the application. It built like a board classification latest. So it did all the steps that mentioned in this Docker file. So this Docker file, it upgraded the pip, it installed the dependencies, it exposed support 80, and running the Python. So let's run this one. Docker run -it. Our image is board classification latest. Classification latest Okay, it's loading the model, it's loading the labels. We have 8 labels, so whatever that the board classification type, it has the 8 labels here. So those things loaded, and it's running this the HTTP server on port 80, right? So we have run this one yesterday, and the next thing, we try to post the image so that like we are predicting what type of boat it is, right? So we try to post the image. So let's go here, copy this curl command, and going back to terminal again. Okay, before that I will just go to downloads where our boat image is. Boats, I will go with the cruise thing, cruise ship. Yeah, so let's paste this one, and let's pause the image, one of the image here. So probably I would take this Norwegian jade, copy this file, paste it here. So basically what it's going to do is it's going to take this image and post it into the Docker container app server, right? So I'm sending that as a application octet stream. So sending this cruise image to this Docker container HTTP server. Okay, it says it's connection refused. I think it's running, right? HTTP 0080. Oh, I think it's running in the local host. Yeah, 00 is local host. Okay, I will make sure this one is running. Clicking this one, it should open. Oh, it's not running here. Okay, I don't know why it's not running. Yeah, this, okay, we need to provide the port number here. I just ran it without providing the port thing. So docker run, and I am passing the parameter for the host address, that is like our local host 80, and the image name, it should be our port classification latest. So it spins up this container, and if I go right now to our 127 0.0.180, now it's sending the result back from the container. So basically like this is the get route that is registered in the Python script that's returning on like in the plain get request. Okay, now this query should be working. Yeah, this is the error we got yesterday. It says like could not pre-process image for prediction, cannot feed value of shape 1227223 for tensor placeholder which has shape 224223. Okay, so this is what we have seen yesterday. So now let's go back to this Python code and see like what's going on. So once user posts the image, that would be coming here, and if it is a octet stream, then it's getting the data and getting this image data, and it's converting that to image here. This is auto generated, right? So this one we have just generated from the custom mission AI portal, but that's not running. So we are just debugging this Python script like why that's not running, and we are predicting the image here, right? So the predict image, That's in this predict.python library. So in this predict image, we are doing like a series of steps, including resizing, converting, and cropping the thing. So if we go back and see the logs here, docker logs container. Okay, it says your CPU supports instruction, that is TensorFlow binary was not compiled to use. I think this is a warning. This one yesterday we have seen, so this one is for warning. But why this error is coming back? So that's what we try to figure that out, right? Still it's coming like this. Okay, let me do this thing. I will docker ps -a docker stop. I'm going to stop this container and I'm going to run that app Python thing from the local so that I can see what's going on really. In fact, like I can debug the Python script that is generated from the custom mission portal to see like why we are having that error, right? Okay, so I stopped one container and I will stop other container also. It's not running, but anyway, like I stopped both the container. So if I'm going to my local host, it should not be reachable. That's right. Okay, so in this boot classification, the code is here in the app directory, right? So I'm opening that in the Visual Studio Code, app.python. So I will try to run from my local machine. Okay, it's running in the TensorFlow and it's loading the model, it's loading the labels, and it's running that the REST server. Okay, now if I go back to this Safari and hit the local host, it should be returning this the custom mission AI model harness. Okay, now let's go back to our other terminal and try to post the image. Okay, we got this error, could not pre-process image for prediction. Going back to here. Okay, it says predicting image. The log says predicting image size is 1280853. It's converting to numpy array and it's cropping it into the center and resizing into the 256 and the crop center, it's still like cropping in the center in like to figure out 227, right? So that's correct, but it says like cannot feed value of shape 227 for tensor placeholder 0, which has shape 224 So what does that mean? I think it's the image is coming as like a width and height as a size 227, but the tensor placeholder 0 that has shape that is expecting 224. I don't know why this question mark. Is it like anything or none, something like that? I don't know, Python guys. Really, I'm just like trying to read the code with my C# and JavaScript knowledge. Okay, so let's go here and match the logs. It says convert to numpy array, right? We will see like where that log statement in the generated code. Okay, it's here. So convert to np array. Yeah, here is a series of steps. It's converting the image to numpy array, it's cropping the center square and resize that square down to 256. Yes, that's right. And we did the crop center also. That's a series of logs here. So crop center and resize, that's in line number 175. And crop center 256 to 227. I think that's here. What is this net? Okay, the network input size is 227. So that's what happening here in this crop center. I think when it's trying to run this session, it's getting the error, right? So we are passing this cropped image, that size is 227, but why it's expecting this 224 here? It says like 227 is coming as an image, but TensorFlow placeholder 0, that is expecting 224. I think that is the input layer. Oh, here it is. The input node, the placeholder 00, that is expecting 224, but we are sending 227. Okay, so if I change this network input size to 224, it should work. Let's go back here. Let's go back here and stop this one, run from the local again, python app.py. okay, it's starting the HTTP server. Now let's run the same curl command that is posting this cruise ship Norwegian image. Hey, we got the error back. So this is what like we want. So I think the fix it should be done here is like the network input size should be 224 because the input node placeholder 0, that is expecting 224, but it was 227 there when we generated from custom vision portal. I'm not sure like this is the customized generated script or it's for like everything, right? So let's figure that out later. I think this is the general code, but if it is not working for like other image datasets, then probably we will update this code and do the PR if it is in the GitHub. So at least for us, like it's working. Let's analyze like what this JSON data is. Or I can put it in the Visual Studio Code. I think that would be saving result.json. Okay, and I'm formatting. Here it is. So this is the JSON result. It's coming back from that the HTTP server. So instead of like hitting the direct endpoint or the prediction URL endpoint that is in the cloud, we just exported that machine learning pre-trained model out, and that is exported in the Docker. Basically that Docker file is like a Python HTTP server which is doing TensorFlow classification using that exported pre-trained models, right? So we have this one ID iteration and the prediction stuff. So the predictions, it says like 2.9. okay, anyhow, like it's epsilon power of 8, that means like 0.00 something, and it is 99.99% confident that this is cruise. That's what the image we have uploaded. So if you want to see like how that image looks like, cruise ship cruise Norwegian. So the image we have uploaded to the localhost server, it looks like this. So we have uploaded that one and it's able to identify like this image is cruise ship, right? So that's what you are seeing in the result here. It is 99.9% confident that it is cruise ship. Now let's go to that some other image. Okay, I will go back. Let's take a sailboat and do the same curl again. Instead of that, we will take a sailboat. I think we can take this sailboat file. So before sending that, okay, so I'm sending this one. It's written back with the result, and the result, I think there is a command to format the JSON from here itself, right? Is it like JSON or print pretty? Mac curl JSON format curl output to display the readable JSON format. Yeah, it's a JSON P. Brew install JQ. Yeah, like this only I want. So brew install JQ, then piping that with the JQ. So let me install that so that we can see that JSON format in the curl command itself. Okay, it's uploading this thing. Oh, it's downloading. Okay, so it's installing this JQ stuff. So what we need to do is we need to pipe the curl request with the JQ. Okay, so this is how that the result looks like, right? So for this sailboat river sailing Florida USA image, it looks like this. It looks like this. So this is a sailboat river sailing happening here. So if you see that the result here, this is epsilon, this is 0.008, another epsilon, and here the tag name is sail, and it is 99.9% confident that this is a sailboat. So it's doing the prediction like very close to that, right? So that's amazing thing. Now what I need to do is I need to upload this update the Docker image. So Docker build boot classification latest. it installing all the required dependencies. It's building the new image. Okay, so Docker images list that contains the boot classification. So Docker run, I will copy the existing script here. So Docker run in the port 8080. Going back to the terminal here. -t and our Docker image is boot classification latest. Started running the container. Now if I run the curl request, okay, I'm not in that the sailboats. I'm not in this the sailboat image. It's not having this sailboat image here. So I would go with, I go to that where that image looks here. So I'm going to that the kayak image. Let's try this one. So I'm posting one of the kayak coast tourism C file. And I'm piping that to JQ so that I can see JSON file here. Okay, it's because I need to. Okay, what's happening? I will copy the file name. I go here and paste the file name and check it. Yeah, that's so it's uploading the image to that localhost server, then it's coming back with the result. So here you can see like it's 99.8% confident that this is a kayak type boot. Yeah, so it's working from the Docker also, right? That's a thing we have looked at in this readme, and it also have that information like how to run in the Azure machine learning studio. So we can just see like how to deploy in the IoT edge device and how we can do it in that Azure machine learning studio and all. So the first thing, I'll go and follow the readme that is generated in this custom mission thing. So it's basically like how to build and deploy this Azure ML image, right? So the first you need a few files from the Docker app. Assuming you are in the Azure ML subdirectory, run the following. Okay, and these 4 files along with this score.py. If anyone watching, just I want to be clear. So our part is like we just exported the Docker file. The one thing we have seen is like in the app predict.python, we need to update this network input size. Previously it was 224, I think. Now it's expecting like a 227, so we have updated this one. Okay, it's not here. 1 second. CD personal port classification. It was 127 before, but that didn't work out. So what we did is in the predict Python, we just changed to 224. So this 224 is expected size for this input node TensorFlow model. So we just provided this, we updated this network input size from 227 to 224, and we run this Docker container. The Docker container basically spins up the Python HTTP server, and if in the Python HTTP server, we can post the image to the REST endpoint, and that REST endpoint is going to predict the image, which is basically doing the TensorFlow run on the exported model of like model.pb and the labels.text. So it's going to analyze your image, and it's going to give the result back like what's that other prediction of that image is, right? So those things we have done. Now what we are going to do is we are going to explore this Azure directory which is exported. So basically this Azure directory is for like if you are running this model in Azure Machine Learning Studio, then how it's going to be. So let's do the step one by one. I'm going to the terminal again. It says like assuming you are in the Azure ML subdirectory. So I will go to the Azure ML subdirectory. It has readme text and score.python file, and we need to copy app requirement text, app predict.python, model.pb and labels.text. So those files are in app directory, so we need to copy that into the Azure ML directory. So I'm going to do that copy apps dash requirements.text to requirements.text here, and cp app predict.py to predict.py, cp app and model and text. So model.pb to model.pb, and another copy script for labels.text. So we have all this file copied into this Azure ML directory. Right. So the next thing is using the Azure ML command line interface. You can create and deploy a service using the following steps. If you haven't previously set up the model management account, please follow the instruction at this link. I didn't have set up any model management account in my portal, so let's go and see and how to set up this machine learning workbench in the Azure Machine Learning Studio here. Okay, it says Azure Machine Learning Workbench application and some other early features were deprecated and replaced in September 2018 to make a way for an improved architecture. So this article is not for Azure Machine Learning Studio user. Okay, this is the deprecated one. Yeah. It went to overview Azure Machine Learning Service documentation, but it should be okay. Overview what is Azure ML, right? But here the link is deployment setup configuration. So we are going to do this image classification only. Basically, like we are using the custom vision AI portal to upload all the images, and that would generate the TensorFlow model. Now we are trying to run that exported TensorFlow model script into the Azure Machine Learning Studio, but this README has like the documentation contains the deployment setup configuration, but that's going to the deprecated one. Okay, let's go here and see. Yeah, we have the Visual Studio Code tools for A also. Okay, let's go back here and continue this one. create. Okay, so quick start getting started with the Azure Machine Learning Service. Log into the Azure portal, creating the resource, creating the Machine Learning Service workspace. And using the workspace, open the notebook. You long files. Here they are having the tutorial for image classification, right? Using our Jupyter, okay, development environment, AML. So this one is for like running this machine learning service in that machine learning studio. I will go and find this Azure machine learning command line interface. Okay, here it is. So to install that the machine learning CLI extension, use the following command. I think for that I need the Azure CLI first. I don't have this one set up here. Okay, install on Mac, brew install Azure CLI. Let's run that in the terminal. Create a manifest to describe the image creation. When this runs, you will see the following output, and then it's creating a new driver here and creating the manifest. Once the manifest is created, they are creating the machine learning image based on this generated from the custom machine portal, and creating a real-time service to serve your model, and that would be serving that deploy the service. Okay, for that I'm installing the Azure CLI so that I can run to create the manifest, basically like following the steps which is described in this readme. In the meanwhile, we will see like how to deploy to the IoT edge device. I think this, how it is going to, okay, the machine learning here, and it's pointing to the preview. I think that's why it's going back to this the common page. So let's go here and see like what are the documentation available. So the Azure machine learning documentation, and this is the Azure machine learning studio where it is like we can drag and drop tool to build, test and deploy that the analytics solution with R and Python. But we are looking for like a Azure machine learning service so that I can export the trained model into that Azure machine learning service and see how that works, right? Train and deploy classification part. Use automated machine learning to train. Okay, So this is what I'm trying to look for. Configuring the workspace. Okay, the basic thing I'm trying to do is like I don't want to do like too much machine learning in this. I just want like everything to be like the automated ML. So anyhow, like I'm uploading that image into the custom vision portal. Then the custom vision is like picking up an algorithm which is the optimized algorithm to do like image classification, and that is exported that the pre-trained model here, and using this pre-trained model I'm using the Docker. Right now what I'm trying to see is like what is this Azure ML service, and whether I can use the Azure machine learning service in what is this. Okay, I can use that Azure machine learning service to have this the train model so that I can fine tune that later if I really want to be right. Okay, let's see whether it's still installing. Let's go to these tutorials and see. So this one, training on the remote, creating a training script. So this train script was like a generated for us using the model. Now I'm looking this deploying the model, retrieving the model, test the model locally, predict the data, 3D configuration. Okay. Okay, I think our scope is like this custom mission. This one I can like read later and see that the one thing I need to look at is like a Azure IoT Edge. So this part we try to look that stuff. So we can deploy this model into these targets, including like IoT Edge or Kubernetes service or machine learning compute for like the batch prediction and all. Since we have used like the compact domain, we can run it in like IoT Edge modules and as well as from the mobile. So let's see. Okay, now let's go back and see. Okay, Azure CLI is installed. And going back here, adding the Azure extension. So it's installing, I hope. Installing our Azure machine learning extension so that I can follow that steps in this readme. Okay, still installing. Hearing the music, I think it's stopped. Okay, it installed. So now going back to this readme, creating a manifest to describe the image creation. So copying this one, and it's including like all these files, including score.python, predict.py, whatever we have copied. And the manifest name I would name as like a board classification. Manifest is not in the okay. Yeah, it has project workspace. It doesn't have this manifest create. Okay, then why it's saying like this? For that, we'll go here and see. So we have added this machine learning thing. We need to create a workspace. Okay, I will copy that and try. Login. I will log into my Azure account. Okay, I think it's logged in. Now if I go to create a workspace and resource group, I would call this workspace like a YAML workspace. Okay, this readme is wrong. We will update this one after we see what's really going on here. So going back to this documentation, machine learning CLI, creating the workspace with the resource group. So machine learning workspace resource group is like okay, so it's going to create the workspace. should be having like existing workspace. I will use the existing workspace itself. So machine learning. Okay, it has the resource group right now. So Siva ML. It's creating the workspace. And once it's created the workspace, we are doing attaching to the AKS cluster. If we want, we need to register the model and create an image that contains your machine learning model and dependencies. So this is what we want to do, right? So basically like we are trying to do this model registration, image creation, deployment into this Azure machine learning service. But here the readme is like a little bit off. It's not like reflecting that the documentation, I think, because it even doesn't have this manifest. Maybe I'm wrong. I need to look this one. So creating an image from the manifest. So this is what we need to do and create a real-time service. So we need to create the image. We need to create the real-time service. So if you see here, the model registration, image creation, and the deployment. So these three things we need to run. Now go back to this. Still the workspace is creating. Okay, I think this readme should be pointing to this stuff. So let's go back here. Oh, space creation is still in progress, so we'll be doing that. In the meanwhile, I think we can wait for that. Okay, it's created this workspaces and everything. That's fine. So once we created the workspace, the next thing we need to do is set the default workspace. I think I already have. Okay, we'll do that. AC configure defaults and Azure machine learning workspace is my workspace, and group configure it as a default, then attaching to the AKS cluster if we want. Okay, attaching AKS name, my AKS resource ID, and group, my resource group, and workspace. Okay, so Azure ML compute target, attach AKS, let's say like a ML AKS, and resource ID is ML AKS resource ID or ML AKS ID. Then group is same group, workspace is ML workspace. Okay, invalid resource ID provide. Okay, what resource ID I have to provide for this? AKS resource ID. Or let me do one thing. Compute target. Okay, I think it would not be created. I need to create that AKS first. AKS create to create a new managed Kubernetes cluster. So it says like creating a cluster with thing. So where would be getting this resource ID? Okay, AKS create group. Group is same group. Namespace is YAML cluster. It's creating this service principal. Okay, I think this readme is like too outdated to follow. So the thing is like probably like in the next stream we will be seeing this Azure machine learning stuff. Right now this Docker container is working. So we just trained our custom mission service and we have uploaded that in the custom mission service portal. We exported the Docker image, and using the Docker image we are able to run. Now we will see like how we can run this Docker container in the IoT edge. I think that would be good instead of like us spending the time on outdated readme. But I will have this in my list so that like I will be running these steps, and probably we will update this probably updated this outdated step into our stuff. I'm not sure like why this manifest is not, maybe I'm wrong. Let me check like why I didn't have this manifest here. Okay, I think there is already an error here. ML service create real time. I'm getting here conversion. Okay, so here are the comments that I ran: machine learning environment setup, account model management create, service create. Okay, I think a lot of people like had this error for this Azure ML CLI or Workbench at least. Okay, we will take that. We will take a look on that later. Anyway, like our Docker container is running. I think that's more than enough for our IoT edge solutions. But we will see why this Azure ML service is not working. Then probably we will try to create the Azure machine learning service using that CLI. Basically, like either why the manifest is not available in this machine learning extension, or what's happening here. So probably we need to try that. And also this readme is going to that the preview one. I think it also needs to be updated, so we will see that one. In the meanwhile, today I'm going to keep it like not too deep on going, because it's spending like more time on creating this Azure machine learning resource and all. So I will stop this one. Going back to the board classification again. Okay, so we have this Docker file. So the first thing I'm going to do is I'm going to create a repository in my GitHub. Board classification. And push this I'm going to push the image, which is the latest Docker image. It doesn't have any secret keys. I think it's everything like baked into the pre-trained model. So I'm going to put it here as MIT license, and I don't need add. Is there a Docker? Python? Yeah, there is a git ignore for Python, and I'm going to put it in the public repository. So I'm creating the repository here, and try to upload this one. Git. Okay, all the file came here, I think. Oh, it's not? Yeah, it's not. I think it came, the license came right here. So add it here. adding both classification Docker images. Oh, I'm hearing the fireworks sound. So I'm staying nearby Magic Kingdom. So Magic Kingdom and Epcot. I'm in like a midway, so I'm hearing the fireworks sound every night. Git status. Okay. So this is pushed into this repository. There is a potential security vulnerability. Flask. Upgrade Flask to version 0.12.3 or later. Okay. Probably like this is tolerable to this project. Oh, they have everything in the readme.txt instead of readme.md. Okay, I will copy this one. Readme.md boot classification Azure custom mission generated files. How to build Docker build, tag your name. How to run locally. So this part I'm going to remove because this one it's not working for us, right? We are going to check that. Okay, I will remove this readme. Git add updating readme here. Okay, so it's pushed into this repository and you can see like how to build the Docker image and how to run locally, and it already has this the exported TensorFlow model and also the labels.txt. So you can use this project to classify the different board types. So let me know how that goes. Let's see. And one another stuff I can see here is like 1 second. What are the other things I have in my list today? So we did this board classification, custom mission generated files and running in the Docker. That's fine. Now the next thing what we need to do is we need to make sure like this Docker is able to run in the IoT Edge module. So for that I need to install basically like the IoT Edge. How it works is like you are basically running this IoT Edge into that Raspberry Pi image. So the Raspberry Pi image will not be hitting your Azure cloud every time. Instead, like it would be hitting your IoT Edge module that's running in the device itself. It would be having this low compute capability. So instead of like hitting that, instead of like taking a picture from the camera, uploading it into the Azure custom mission service to predict what that image it is. Instead of that, we are going to spin this Docker container in one of the Azure IoT Edge module, and our custom app code that's running in the Pi, it's going to hit this Docker container script. It's going to hit the URL which is running in this IoT Edge module, and do this machine learning stuff from the Pi itself, from the device itself. So that's what we are going to achieve in this, like a in like a couple of streams. So let's see. So what we need to do is, let's go to the IoT Edge documentation and see like how to create the IoT Edge, and from that onwards we would be seeing here. So if you go to the documentation, Azure IoT Edge, it has step-by-step tutorials already. So this is what we are going to do, like a classify images with a custom mission services module. But you can use this IoT Edge module for different purposes. You can see like they're using for Azure functions, and they're using for stream analytics, and also machine learning thing. So now we are going to do this custom mission service to do the image classification. Basically we are going to do this stuff. Okay, so for building the image classifier, we need to create a new project. So this part we have done. They are using that to classify the leaves, but we have used that one for classify the board service. So we trained the classifier, we exported the module. Now what we need to do is we need to create an IoT Edge solutions. So now you have the files for a container version of your image classifier on your development machine. In this section, you can configure the image classifier to container run as an IoT Edge module. For that, they are creating the IoT Edge solution workspace, adding the image classifier, which is basically the files they have downloaded, and creating a simulated camera module. So everything running in the Python, and preparing a deployment manifest, adding your registry, build and deploy your IoT Edge solution, and they are getting the classification results. So this part we have to do, but this documentation is like they have run everything in like Python. But what we are going to do is we are going to create a Node.js project. So we are going to create a Node.js IoT Edge module to run this classification image from your machine, right? So basically we are going to simulate the same thing, either camera module, or probably I will spin up my Pi with the actual camera, so that like whenever there is a boat image coming on, then it would be identifying that what type of boat it is, and it will tell the same, or it would display that in the result. So we will be doing that part. So we will follow this thing. For that we need to create like a IoT hub and all. So these IoT fundamentals we would start, but I think it would not be better like if I start now and leave it in like a half an hour or something. So let's start this IoT stuff in like in the fresh stream. The next stream in my schedule is like it's going to start on Saturday morning 9 a.m. So on Saturday morning 9 a.m. we would be creating this Azure IoT project, and also Azure IoT Edge module to run this exported pre-trained TensorFlow model. So basically like the Raspberry Pi, and whenever there is a boat crossing in the sea or something, then the Pi camera is going to take the picture and see like what type of boat it is. So those things we would be seeing in like the next stream. I think today we have pretty much done. So today what are the things we have achieved is like we exported this Docker, and we try to fix this we try to fix this app.py. Sorry, we try to fix that the predict.python file where it's the network input size is 227 before, but that's not worked. It threw the error, so we just changed to 224. I'm just wondering like whether it has anywhere in the open source so that we can update that. Okay, there is already here changing network input size. That's the different one, right? Okay, 227. The model requires this size, but it's expecting 224, right? So let's see. Where is the documentation for that? The name last zero refers to tensor, which does not. Okay, I'll go to github.com and go to the Microsoft organization. And set it here. Okay, there is a code here. Network input. Yeah, this what it's working only when it is 224. Commit major change of validation. Okay, I'm not sure. I need to make sure like before changing this I'm going to try like a different image data sets, and I'm going to see like whether the same error is happening, because we are using this output layer lost 0, right? So TensorFlow lost 0, TensorFlow lost 0, image size or bound size 224 or 227. Maybe it's because of like TensorFlow version or something. Yeah, this one. Mainnet challenge 2012 accepted images of size 227, 2073. If as a fun side, if you read the actual paper, it claims that input images were 224, 224, which is surely incorrect because it's quite okay. Yeah, I need to look at this one like why it requires a change even if it is generated from the custom vision portal. I think it's not anywhere in like in the Microsoft organization, so that I can go and see like do that the pull request so that it would be generated. Maybe I'm doing something wrong either in the TensorFlow version or the Python version. Anyway, I'm running in the Docker image. So I think once I change the network input size from 227 to 224, then it started working. So that's what we have fixed that, and we are able to predict the image using the Docker container. Next thing we try to do that in the Azure machine learning service using the documentation here, but that documentation it's not working with this manifest. Maybe I need to add like some more extension in the Azure machine learning, but I just followed that the readme in the Visual Studio docs. That seems working, so probably like in the next session we will be trying that as well. But our scope for this series is like not for the Azure machine learning service. Our thing is like using this Docker, we are going to deploy that in the IoT Edge module, so that in the IoT device the IoT Edge module can run, and instead of hitting the cloud URL from the device, we are just hitting that IoT Edge Docker container and predict that image classification or image object detection, those things from the device itself. So we would be doing that stuff in next stream. Till then, I think it's time to sign off. If you have any, okay, before closing this off, if you have any questions or if you have anything, then just like ping me. Otherwise, come and stop by in this stream. In like in the schedule, I'm going to stream this. I'm going to do the stream on Monday, Wednesday, Thursday, 8 p.m. and Saturday morning, 9 a.m. EST. So please come stop by and feel free to chat. We will learn together on this machine learning and IoT devices. Till then, see you guys. See you.